So in homework 13, we looked at vector spaces, and in particular, we looked at vector spaces in the context of Rn. And the idea was we defined vector addition and scalar multiplication in Rn, and then we identified that these 8 properties held for vectors in Rn. So what we're going to do in this next homework is generalize this idea of vector spaces to apply to sets of objects that aren't necessarily objects living in Rn. So we're going to take this set of properties, we're going to extend it just a hair and reorganize it. So we're going to have 2 closure axioms, and we worked with closure in previous homework assignments. And then we're going to take the axioms from the previous homework 13, these 8 axioms, and we're going to group them based on addition and scalar multiplication. So same 8 axioms that we've been working with. So what we're going to do is, in the next set of videos, we're going to say, look, it isn't just vectors in Rn that can be vector spaces. Any set of objects, for example, 2 by 2 matrices, second degree polynomials, functions, any set of objects for which you can define addition and scalar multiplication. If closure under addition and scalar multiplication is achieved, and these algebraic properties hold, these 8 algebraic properties hold for addition and scalar multiplication, then we're going to say that set of objects is a set of vectors and forms a vector space under addition and scalar multiplication. And most of the examples we're going to be working with the scalars. We're going to let the scalars be real numbers. But the other thing to realize is that it is okay to look at complex vector spaces where the scalars are complex numbers instead of just the subset of complex numbers that are the real numbers. So that's going to be the focus of the next set of videos, is looking at different sets of objects that meet the criteria of being a vector space.